Okay, say you have a basis set, okay, but they are not orthonormal. Now, how to make how to come up with a new set which is an orthonormal basis, okay, so that it will be easy for me to calculate the coefficients easily, okay. So that can be done through a procedure called Gram-Schmidt. I think that's the spelling. I'm not sure. Okay, DT. Okay, so you are aware of that procedure. Okay, so say for example, once again we will go to R2 space. Let's say 1 0 and then 1 1. They are the bases, right, for R2. But are they orthonormal? Not even orthogonal, right? So now how to orthogonalize? Okay, say let's say this is u1 and u2. Okay, the new set which we are going to create is v1 and v2. Okay, so what is v1? Okay, v1 is same as u1. Okay, but the normalized one. Okay, divided by square divided by the magnitude, which is square root of u1 dot u1, right? Because that's the magnitude. Sometimes if the u1 is not normalized, let's say this u1 is instead of 1 it's 2, let's say. Okay, then the magnitude is 2 not 1, so we need to normalize it, right? So that's what v1 is. Okay, so what's v2? So v2 is from u2, sorry, come again. So from u2 I am removing the part uh, which is along v1. Okay, so u2 minus u2 dot v1. So you know what is the dot product, right? So the dot product in an R2 space can also be seen as a projection, right? Say for example you have this vector, let's say that's u2, and another vector, let's say v1. Okay, u2 dot v1, let's say v1 is a unit vector. Okay, u2 dot v1 is nothing but if I project this u2 vector along this v1, what is that answer? Okay, so that's what u2 dot v1 is. Okay, so in from u2, if I remove that projection part, what will I have remaining? This part, right? And also that part is perpendicular to this v1, right? So but u2 dot v1 is just a magnitude, okay, not a vector. But what is this vector? No, sorry, v1 is actually let me read right clearly. Say this is u2, okay, but this is v1. Okay, but the projection u2 and v1 is this part, right? And what we need is finally this part is what we need, which is u2 minus this vector. But this vector's magnitude is known, which is u2 dot v1. What is the direction? No, the v1 itself is the direction because v1 is a unit vector, right? So what I can do is I could write like this, right? Where this is a scalar, this is a vector. So together it's a vector. Okay, so now, so if you calculate, you're getting this part, but that's not normalized, right? So what you have to do is divided by under root of this quantity. Okay, so u2 minus dot 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 whatever in the denominator, so that will provide you v2. Okay, so why don't you try for this u1 and u2? What is v1 and v2? So 2 0 is u1, 1 1 is u2. So for this example, v1 is 1 0 and v2 is minus 1 by 2 1 by 2. Mm, no, because if you take a dot product of these two things, you will not. So tell me what is u2 minus u2 dot v1 into v1. So u2 is 1 1, right? And then u2 dot v1 is, so this is v1 minus, what is u2 dot v1? Yeah, what is that value? No, 1. 1 0 is v1, u2 is 1 1. So the dot product is just 1, right? 1 into v1, which is this one, right? 1 0. So the answer is 0 1, right? 0 1, but you need to normalize it, but even if you normalize it, you will still have 0 1. Yeah, now you have got 0 1, right? So is it fine? So now similarly, what you need to do is say if I give a polynomial, let's say 1 x x square dot dot dot. Okay, say for all polynomials, they are not orthonormal. Okay, for some interval, I will let you know the interval. Um, how to, I mean, what is the orthonormal basis? Okay, for that you need to use this procedure. Okay, by the way, say for example, once you calculate v2, how do you calculate v3?
V3 is equal to u3 minus
v3 is equal to u3 minus
u3 into v2
u3 into v2
into
v2,
magnitude.
not just that, minus u3 dot v1
Dot
v1. Okay, so you need to remove whatever you have calculated earlier. Okay, that part you need to remove, and then you need to normalize it. Okay, so that's how you need to calculate. Okay.